Hi students, let us learn about the image formation by spherical mirrors in this session. To study the image formation by spherical mirrors, first you must learn 4 rules. Rule 1 is that if the incident ray is parallel to the principal axis, the reflected ray will pass through the focus. For this concave mirror, this is the principal axis and this is the incident ray. The incident ray is parallel to the principal axis. After reflection, the reflected ray passes through the focus. For this convex mirror, this is the principal axis, this is the incident ray, and this is the reflected ray. As this is a convex mirror, you extend this reflected ray backwards to the focus. What is the second rule? Second rule states that if the incident ray passes through the focus, the reflected ray must be parallel to the principal axis. For the concave mirror, this is the incident ray and this is the reflected ray. The incident ray passes through the focus. This is the focus. This is the incident ray. And it strikes at this point. This is the point of incidence. And then it gets reflected. This is the reflected ray. This reflected ray is parallel to the principal axis. For the convex mirror, this is the incident ray and this is the reflected ray. As this is a convex mirror, extend the incident ray to the focus. You can see the reflected ray is parallel to the principal axis. That is the second rule. What is the third rule? If the incident ray passes through the center of curvature, the reflected ray is traveling along the same path. This incident ray passes through the center of curvature. And this is the reflected ray. It is traveling along the same path. For the convex mirror, this is the incident ray and this is the reflected ray. If the incident ray is passing through the center of curvature, the ray is reflected back along the same path. That is the third rule. What is the fourth rule? If the incident ray is oblique towards the pole, then the reflected ray is also oblique. That is the fourth rule. This is the incident ray. As you can see from the diagram, it is not parallel to the principal axis. It is oblique and it falls at the pole of the mirror. And after striking the mirror, it is reflecting in this way. It obeys the laws of reflection. The angle of incidence will be the same as angle of reflection. In all the cases, the laws of reflection is obeyed. This is the incident ray and this is the reflected ray. This is when the ray is oblique and not parallel to the principal axis. Now that we know the rules, we can draw the ray diagram to study the image formation. First, let us learn concave mirror. For a concave mirror, there are 6 possible positions where an object can be placed and an image is formed. By changing the position of the object from the mirror, different types of images are formed. First, you place the object at infinity, then between infinity and center of curvature, at center of curvature, between center of curvature and focus, at focus, between focus and pole of the mirror. These are the 6 possible positions of object. The position, the nature and the size of the image formed depends upon these positions of the object. You can see a concave mirror in this diagram. First, you keep the object at infinity. At infinity means far away from the mirror. The second position is between infinity and center of curvature. That is, the object is beyond C. Then the object is at C. Then the object is kept between C and F. Then at F, then between F and P. P is the pole of the mirror. These are the positions of the object. In each case, you will get different type of image. When the object is kept at infinity, let this be the incident ray AB. This ray is AB, and let this be another incident ray, that is ray DE. At this point, the incident ray AB gets reflected. At this point E, the incident ray DE gets reflected. AB and DE, these incident rays are parallel to this principal axis. If a ray is parallel to the principal axis, after reflection, it should pass through the focus as per the rule 1. You can see here it is passing through the focus. At focus, you will get an image which is real, inverted and highly diminished. Real images are obtained for a concave mirror. It is called real because this reflected ray and this reflected ray actually meets at this point. It is real. That is why it is called real image. Real images can be obtained on a screen, and always you will get the real image in front of the mirror. The object is kept beyond C. This is the object. To draw the ray diagram, you need 2 incident rays from the object. Say this be the first incident ray, and let this be the incident ray 2. The incident ray 1 is AD. The incident ray 2 is AE. The incident ray AD, that is ray 1, strikes at this point and it gets reflected and passes through the focus as per rule 1, because this ray is parallel to this principal axis. It should pass through the focus. The second incident ray, this one, that is ray 2, is passing through the through the center of curvature and striking the mirror at this point. According to rule 3, it should reflect back along the same path, that is about ray 2. If you have 2 incident rays, you will get the image at the point where these 2 reflected rays meet. This is the reflected ray for ray 1 and this is the reflected ray for the ray 2. These 2 rays this one and this one. These two rays meet, actually converges at this point where you get the image. The image is real, it is inverted, and it is of the smaller size. The object size is this much. Look at the image size, it is smaller. When the object is kept beyond center of curvature, image is obtained between center of curvature and focus, and the image is real, inverted, and diminished. Real images are always inverted, and you will obtain in front of the mirror. What happens to the image when the object is placed at center of curvature? AB is the object which is kept at the center of curvature. This is the ray 1 and this is the ray 2. Ray 1 is ray AD and it is reflecting like this. Ray 2 strikes at this point and it is reflecting like this. Look at ray 1. Ray 1 is parallel to the principal axis. The incident ray is parallel to the principal axis. This is the incident ray, this is the principal axis, both are parallel. Therefore, the reflected ray should pass through the focus. This point is the focus. In the case of ray 2, the second incident ray, let this be the second incident ray. This incident ray is passing through the focus and strikes at this point. It is reflecting. If the incident ray is passing through the focus, the reflected ray must be parallel to the principal axis, as we learned in the rule. Where will you get the image? The image is obtained at the meeting point of the reflected rays. This is the reflected ray 1, this is the reflected ray 2. It meets at this point and you will get the image at that point. If you place the object at center of curvature, you will get the image at the center of curvature. The image will be inverted and it is of the same size as that of the object. The image is also real. Now place the object between C and F. This is the object. Let this be ray 1 and let this be ray 2. Ray 1 strikes at the mirror at this point and this is the reflected ray, ray 1. In the case 2 or the ray 2, this is the reflected ray. Ray 1 is parallel to the principal axis and after reflection it passes through the focus. Whereas ray 2 passes through the focus and hence after reflection it must be parallel to the principal axis. You will get the image at the meeting point of these two reflected rays. This is the meeting point where you get the image. This image is obtained beyond C. It is inverted, it is real but enlarged. When the object is placed at focus, let this be ray 1 and let this be ray 2. Ray 1 passes through the center of curvature and hence reflecting along the same path, whereas ray 2 is parallel to the principal axis and hence passes through the focus after reflection. The reflected rays neither converge nor diverge. The reflected rays are parallel. You will get the image at infinity. It will be enlarged, real and inverted. Now place the object between F and P. The two incident rays are ray 1 and ray 2. Ray 1 passes through the center of curvature and hence reflecting back along the same path, whereas ray 2 is reflecting and passes through the focus. You extend these reflected rays backwards and it will meet at this point where you will get the image. You will get an erect image which is enlarged. This is the object size and this is the image size. It is enlarged and it is virtual. Virtual images are obtained behind the mirror. Let us summarize the position, size and nature of the image. When the object is at infinity, the image is at the focus. And when the object is at focus, the image is at infinity. Here it is highly diminished as the object is at infinity, it is far away. Therefore, it is highly diminished. Whereas at focus, focus means closer to the mirror. The image is highly enlarged. In both these cases, the nature is real and inverted. When the object is at the center of curvature, the image is also obtained at center of curvature and it is of the same size, real and inverted. If you want to get the image of the same size, the object should be at the center of curvature. When the object is kept beyond the center of curvature, the image is obtained between F and C. When the object is between C and F, you will get the image beyond C. When it is beyond C, anyway it is far away from the mirror. Therefore, the image is diminished. When it is between C and F, it is closer towards the mirror. Therefore, the image will be enlarged. In both these cases, the image is real and inverted. If you move the object towards the pole, that means if the object is between F and P, you will get a virtual enlarged image, which means that this concave mirror can give you both real image as well as virtual image. Now let us study the image formation of convex mirror. As you know, convex mirror is a diverging mirror. In concave mirror, we learned 6 positions for the object. But for convex mirror, you have only 2 positions for the object. The first one is the object at infinity. When the object is at infinity, the incident rays are parallel to the principal axis. This incident ray, let this be ray 1 and this be ray 2. Ray 1 strikes at this point and reflects like this. Ray 2 strikes at this point and it is reflecting in this manner. You produce these reflected rays backwards as this is a convex mirror. It will meet at focus, which means you will get the image at the focus. When the object is at infinity, you will get a very small, highly diminished image at focus, which is virtual and erect. These rays appears to diverge from this point. That is why It is called virtual. Virtual means not real. It appears to diverge. Virtual images are obtained behind the mirror, and virtual images will be always erect. Now, when the object is placed between pole and infinity, let this be the object. It is placed in front of the mirror, anywhere between the pole and infinity. You have two rays. This is, say, this ray 1 and this be ray 2. Ray 1 is parallel to this principal axis. Therefore, after reflection, this should pass through focus. This is the focus. What about ray 2? It passes through the center of curvature. Therefore, it is reflecting back along the same path. When these reflected rays are produced backwards, it intersects at this point. At that point, you will get the image. The image is obtained at the intersecting point. The image is small. Image is virtual. Virtual images are always erect. Virtual images cannot be obtained on a screen. And the image is obtained between P and F. P and F. This is the image. At infinity, you will get the image at focus and behind the mirror. It is highly diminished, virtual and erect. Between infinity and the pole, you will get the image between P and F. It is also behind the mirror, diminished, virtual and erect. In both these cases, the image is virtual and erect, and it is diminished. In this session, we learned about the image formation by spherical mirrors. For that, first we learned the 4 rules. Rule 1, that is, if the incident ray is parallel to the principal axis, the reflected ray should pass through the focus. Rule 2, if the incident ray passes through the focus, then the reflected ray must be parallel to the principal axis. The third rule, if the incident ray passes through the center of curvature, the reflected ray will reflect back along the same path. The fourth rule, if the incident ray falls oblique at the pole of the mirror, then the reflected ray is also oblique, obeying the laws of reflection. Using these rules, we learned the image formation in concave mirror as well as in convex mirror. The position, size and nature of the image will be different for different positions of the object. For the concave mirror, there were 6 positions for the object, but for the convex mirror, we have only 2 positions for the object. And we learned all the different types of images in all these cases. We will study the uses of these spherical mirrors in the next session. See you.